Question 2. Ethanol and ethanoic acid are reacted to make an ester, ethyl ethanoate and water. It's an equilibrium reaction. A mixture of 8 times 10 to the minus 2 ethanoic acid and 1.2 times 10 to the minus 1 ethanol is allowed to reach equilibrium. It looks as if we've not started with any ethanoic acid or water. The equilibrium mixture is placed in a graduated flask and the volume made up to 250 centimeters cubed of water. A 10 centimeter cubed sample of the equilibrium mixture is titrated with sodium hydroxide. The ethanoic acid in this sample reacts with 3.2 centimeters cubed of 2 times 10 to the minus 1 moles of sodium hydroxide. So the very first step before we start unraveling this is that I've got a volume and a concentration of sodium hydroxide. So first of all we need to work out moles. We wouldn't be given a volume and concentration unless we needed to work out moles. So let's do that. Sodium hydroxide is titrated with the ethanoic acid. Concentration is 2 times 10 to the minus 1 or 0.2 equals moles. Concentration is moles divided by volume. Now I need to convert this volume centimeter cubed into decimeter cubed. A small unit like a centimeter cubed into a larger unit like a decimeter cubed, I divide by 1000. So 3.20 divided by 1000 is 0.032. Number of moles, 0.2 times 0.0032 is 0.00064. So that's the number of moles of sodium hydroxide that I've got. What's it reacting with? Well, it's been titrated with this mixture. So when it's titrated with the mixture, it's going to react with the ethanoic acid. Sodium hydroxide is a base and it reacts with acid, so it's going to react with the acid. So sodium hydroxide and ethanoic acid will make water and a salt called sodium ethanoate. And 1 mole of sodium hydroxide will react with 1 mole of ethanoic acid. But I haven't got 1 mole of sodium hydroxide, I've only got 0.00064 moles of sodium hydroxide. So therefore 0.00064 moles of ethanoic acid are in the sample. I've just found out how much ethanoic acid is in the sample. Now when we take a sample, it means we're taking a small part from the mixture. We had 250 centimeters cubed of the mixture and we took 10 centimeter cubed. So 10 centimeter cubed, the sample of only 10 centimeter cubed contains 0.00064. So by a little bit of maths I can divide by 10 and 1 centimeter cubed would contain 0.00064. So 250 centimeter cubed, the original sample, multiplied by 250, there are 0.016 moles of ethanoic acid in the equilibrium mixture. Another way of doing it, if your maths is slightly stronger, is to work out that 10 centimeter cubed out of 250, divide 250 by 10, so 250 centimeter cubed is 25 times larger than the sample. Just multiply 0.00064 by 25 and you'll come out with the same answer. Now, this is where we need to do a little table. The little table, let's work out the little table. At the start, the ethanoic acid is 0.08 or 8 times 10 to the minus 2. It tells you that in the question. The amount of ethanol is 0.12 or 1.2 times 10 to the minus 1. There's no ethyl ethanoate and no mention of water either. So that's at the start. It's always helpful to lay it out like a table like this. Then at equilibrium, we've just worked out that there's 0.016 ethanoic acid made. 0.016 moles of ethanoic acid are in the equilibrium mixture. So this 0.016 is what we've just worked out. Now then, if I started with 0.08 moles of ethanoic acid and I've worked out that in the equilibrium mixture is 0.016, by subtraction I can work out how much ethanoic acid has been used up from the start to the finish. So 0.08 take away 0.016, I've used up 0.064 moles of ethanoic acid. So 1 mole of ethanoic acid reacts with 1 mole of ethanol to make 1 mole of ethyl ethanoate and 1 mole of water. So if I've used up 0.064 moles of ethanoic acid, I must have used up 0.064 moles, the same amount of ethanol, and I must have made the same amount, 0.064 moles of ethyl ethanoate, and the same amount of water, 0.064. So I've used up 0.064 moles of ethanol, and I've made 0.064 moles of ethyl ethanoate, and I've made 0.064 moles of water. Let's work out how much is in the equilibrium mixture then. The ethanol I started with was 0.12. I've just used up 0.064 moles of it, so I can work out how much is left, 0.056. I didn't have any ethyl ethanoate to start with, and I made 0.064, so that's how much I've got in the mixture. And the same for water. I didn't have any water to start with, I've got 0.064 moles of water made. The last bit, the Kc. The Kc is the concentration of ethyl ethanoate multiplied by the concentration of water, divided by the concentration of ethanoic acid, and divided by the concentration of ethanol. There's no numbers in front, there's just ones in front, so each of these concentrations are to the power 1. So that's my Kc, concentration of ethanoic acid multiplied by the concentration of water, divided by the concentration of ethyl ethanoate multiplied by the concentration of water, divided by the concentration of ethanoic acid, divided by the concentration of ethanol. Straightforward expression for a Kc from an equation at equilibrium. So let's have a look what I've got at equilibrium. Concentration of ethanoic acid, ethyl ethanoate rather, is 0.064, 0.064 for the concentration of water, divided by the amount, the concentration that I've got, 0.016 here, and 0.056 moles of ethanol. I could divide by the volume, 250 centimetre cubed, but because I'd be dividing by 250 centimetre cubed twice on the top of the equation and 250 centimetre cubed twice on the bottom of the equation, they'd all cancel out. So I'm just going to use the number of moles. The number of moles will work out exactly the same as if I'm converting each of these by dividing by 250 centimetre cubed. Another way of working that out is that I've got 2 moles of reactants, 1 mole of ethanoic acid and 1 mole of ethanol, and I've got 1 mole of ethyl ethanoate and 1 mole of water. If I've got equal numbers of moles of reactants and products, then I don't need to divide by volume. So I can just use these straight numbers without dividing by the volume at all. The volumes would cancel on the top and the bottom because there's equal numbers of moles of reactants and products. When I work all that out, it turns out to be 4.57.